A rocket is launched upward at an angle of 42 degrees and at a speed of 40 meters per second above the horizontal. We will find A, what is the max height, B, what is the total flight time, and C, what is the horizontal distance traveled. To start this problem, we want to start by organizing the information that we have and drawing a diagram, labeling the 42 degrees at which the rocket will be launched, and labeling the hypotenuse of the triangle of 40 meters per second to show the speed in which the rocket is being launched. We also want to make sure that we draw and organize a chart in which we can separate the values for the horizontal and vertical components. In order to begin solving this problem, we need to be able to recognize that we need to use trigonometry in order to solve for the horizontal and vertical initial velocities. We will be using SOHCAHTOA to do so. We will be using sine, which is opposite over hypotenuse, and cosine being adjacent over hypotenuse. The key equations to solve for this is h sine theta equals your horizontal initial velocity and h cosine theta equals your vertical initial velocity. Now, using the information given in the problem, we will be plugging in 40 for h and 42 for theta in the equations h sine theta equals your horizontal initial velocity and h cosine theta equals your vertical initial velocity. Our equation to find our vertical initial velocity will now be 40 cosine 42, giving us the value of 29.73 meters per second. And our equation for finding our horizontal initial velocity will now be 40 sine 42 equals 26.77 meters per second. Now that we know our initial velocities for our horizontal and vertical components, we can put it into the chart. Because we know that our vertical initial velocity is 29.73 meters per second, we can also know now that our final vertical velocity is negative 29.73 meters per second. Because our horizontal initial velocity is 26.77 meters per second, the final velocity is the same. The next piece of information that we can fill out in our chart is our acceleration. For the vertical component, we know that negative 9.8 meters per second squared is the acceleration because of gravity. However, for our horizontal component, we know that 0 meters per second squared is the acceleration because it is not accelerating or moving any quicker. Using the information that we have gathered in our chart, we can now use the equation t equals the final velocity minus the initial velocity over our acceleration. We will use the vertical components to plug in our numbers into the equation. So t equals negative 29.73 meters per second minus 29.73 meters per second over our acceleration of negative 9.8 meters per second squared. So t equals 6.07 seconds for the whole trip. This is our answer to letter B. What is the total flight time? The rocket was in flight for 6.07 seconds. Once again, we want to plug our information back into the chart so that we stay organized. Now that we have the time for our total trip, we know that at our maximum point, which is our halfway point, and the point in which the rocket is about to turn back to the ground, it is exactly half of our total trip. Therefore, our new time is 3.035 seconds for our horizontal component. Once again, the chart should be updated. Now we have all the necessary information to fill out our displacement equation, which will help us find out what the max height that the rocket reached was and what the horizontal distance traveled was. The displacement equation is displacement equals initial velocity times time plus 1/2 times acceleration times time squared. In order to find our vertical displacement, which is the max height that the rocket reached, we need to plug in our numbers. This would equal 29.73 meters per second times 3.035 seconds plus 1/2 times negative 9.8 meters per second squared times 3.035 seconds times 3.035 seconds. This would equal 45.09 meters. This is the max height that the rocket reaches. Our last part in solving this problem is to find what the horizontal distance traveled was. We will be using the same displacement equation in order to find the horizontal displacement. Plugging our numbers in from the horizontal components, displacement equals 26.77 meters per second times 6.07 seconds plus 1/2 times 0 meters per second squared times 6.07 seconds times 6.07 seconds. Because our acceleration in this equation is 0 meters per second squared, we only need to worry about the 26.77 meters per second time 6.07 seconds. In this displacement equation, we only need to worry about the initial velocity times time. Therefore, we get a final answer of 162.49 meters as the horizontal distance traveled.